So our next presenters are with Couchbase. They are a NoSQL data store and then some. And I don't want to spoil their surprise here. So yeah, I learned a lot about Couchbase today, talking to the folks here from Couchbase, and really, I told them that I probably spoiled my whole weekend actually trying it out. So anyhow, we're a little bit ahead of time, so we do have a little bit of space. Not too much, just a couple minutes. But that said, my two presenters here are Steve, who's the founder. You were the founder of the open source offering, yes, and his engineering manager, Tanya.
I'm Talina.
So, and I don't even pronounce her last name. I've already forgotten how to do that. So, anyhow, so if you two want to just speak up, I'm going to turn this mic off. Make sure you, Talina, turn your mic on there for our streaming participants. And away you go. Thank you, guys.
All right, thank you very much. John, that was a very kind introduction. Thank you. Also, AWS for putting on this event, and Omnistrate, too, for shepherding this thing. So, yes, my name is Steve Yian. I'm one of the co-founders of Couchbase. But be not afraid, I'm, like many of you, a technical guy. So afterwards, come ask me questions, whatever you want to ask, whatever you want to talk about. It'll be fun. So agenda-wise, we're going to talk a little bit about our SaaS lessons learned. What were the lessons learned that we had? Ideally impart some of the challenges that we ran into in terms of standing up our database as a service. And my co-presenter is Talina, and she is one of our top engineering managers who worked on the DBaaS product. So there we go. First of all, we're going to talk a little bit about what is Couchbase. And I do have, I guess, this bias or this opinionated thought that, yes, Couchbase is one of the probably most underappreciated or underrated technologies or data platform databases that you all probably are not familiar with. So good news, you got to hear about it today, right? And back in the day, I was involved in a lot of different technologies. I remember multiple decades. John mentioned doing assembly language programming, and I remember those days like crazy, and all the different waves of technology from PCs and client server and internet and onwards to today. And today, nowadays, we're involved in AI. It is the most exciting, the most amazing technology shift, the tsunami, this tidal wave of change that's going to be happening to our industry. And oh my God, it's going to be crazy. It's going to be exciting. So, and we're also going to talk about our SaaS lessons learned. Now, what is Couchbase? Couchbase is a very fast, high performance SQL++ document database. And what I mean by documents, I mean JSON documents. Back in our early journey, some of you might remember this wave or this phase of the industry called the NoSQL wave. And Couchbase was an early NoSQL startup. And what we did is we adopted in our early days the JSON data format. We made the bet and say, hey, it feels like, hey, is it going to be XML? Is it going to be something else? It feels like JSON is going to be the thing that, like, there's going to be more JSON than ever before in our lives. And when you layer on, like, yes, all your applications are probably generating JSON left and right? So it was the right bet. But you layer on top of that AI. Is AI, agentic applications, going to be generating more JSON or less JSON in our futures? Well, yeah, it's going to be more JSON, so not a bad bet. But what are people building with Couchbase? Well, they're building global applications. So in these global applications, they're mission critical, business critical. They need the highest performance. You're talking millions of bops per second, super low sub-millisecond latencies, all sorts of things that are like, you need highest availability, highest reliability. These things have to be robust. They cannot go down. And they might need to be distributed, not only within a single cluster, which you can do with Couchbase. You can add more and more server nodes to a single Couchbase cluster in order to scale it out, in order to have more performance. But you can have more than one cluster, and you can have an AWS West cluster synchronized up with an AWS East cluster, an APAC region. You might have some other clusters or hybrid cloud or your own on-premise installations. All are part of Couchbase features. This cross-data center replication, done. If you want to say, hey, Couchbase, can you run this stuff for us? No problem. We have our database as a service. It's called, the product line is called Capella, but we will handle that for you too. There's also a lightweight version of Couchbase called Couchbase Lite. that will run in iOS or Android. So on your pocket, in your purse, on your tablet, in your kiosk. And if those devices on the edge are occasionally disconnected or occasionally connected, no problem. That synchronization, that replication, that conflict resolution, those are the feature sets of Couchbase, of the Couchbase data platform. So let's talk a little bit about like different companies or different industries that have actually chosen us. There's like from retail, from travel, from technology, telcos and gaming. One of the companies I like to talk about is related to this quote from science fiction, which is about, hey, the future is already here. It's just unevenly distributed. And I got to tell you, the future is already here. It's just already distributed to cruise ships. Now, cruise ships are amazing things. So you're talking Carnival Cruise Lines, Princess Cruise Lines, Royal Caribbean. These are like customers that have deployed Couchbase. And when you think about like a cruise ship, it's like, well, take this building that we're in right now, flip it over onto its side, and like, decide to make that move through the ocean. That's crazy. But the amount of IT technology that they have deployed in these cruise ships is also crazy. It's censored up the wazoo. Thousands and thousands of RFID sensors deployed in cruise ships. Why do they do this? Well, when you check in for your cruise, they say, hey, by the way, have you installed, sir, this Carnival Cruise Line's application on your smartphone? Oh, let's give you this RFID pendant. Let's give you, and you and your family, this wristband. So that while you're on your cruise and you're enjoying yourself, you could say, hey, well, here, you come up the elevator onto the 19th floor, the 19th deck. Holy moly, 19 floors on a moving boat. That's already amazing. And the elevator doors open. And you see these beautiful, wall-to-wall screens. And it says like things like, oh, by the way, hey, there's scuba diving lessons that are like going to be there in the next 2 hours. Would you be interested? Talina might be exactly interested in that kind of thing. There are drinks 50% off on the Lido deck. That's a thing that I might be interested in, right? And it just happens to know stuff like that. So the amount of data that you have behind the scenes in order to slice and dice it and provide the right information at the right time for the right experiences to increase the value for the guests, is there going to be more of that in the future or less? Well, there's going to be more, right? The applications that you can build on top of that kind of data layer. If you aspire to that kind of thing for your applications, whatever you're trying to build, please take a look at Couchbase. Now layer on top of that AI. In the terms of the LLMs and generative world, right? To provide the right kind of experience for the user. That's going to be crazy. So we're very excited by these kind of things. I mentioned this thing called SQL++, rather than taking up all the time. Basically, we worked with the father of SQL. His name is Don Chamberlain. Mr. Don Chamberlain, he's an IEEE fellow. He's an ACM fellow. He was one of the inventors of SQL. But we decided, hey, Don, if we were to extend SQL to the semi-structured world, not just like flat rectangular tables or relations, but if there's like substructure, if you have like a product JSON that has like sub-variants and sub-manufacturers, and you want to slice and dice it, how should you do that? Well, there are new operations like unnest or nest and all sorts of cool things in SQL++. Check it out. It's actually sort of a de facto standard now. Not only do we implement it, multiple open source projects or SQL engines or data engines now implement it. AWS has an implementation of SQL++. Very cool. And now AI can access this kind of like semi-structured data very smoothly. With that, I'm going to turn it over to Talina. She is going to talk about Capella, which is our database as a service. So,
Yes.
all yours.
Awesome. Hi, everyone. Very nice to meet you all here, and thanks for attending, and thanks for listening to me. So, thank you, Steve. You shared your experience of actually building a NoSQL database from scratch as an open source database, which is highly scalable and performant. And I think at this stage, at Couchbase, we had a database that was serving the needs of offline availability of data, online availability, and it was also cloud native. The question that was in front of us at that point was, we've nailed the 0 to 1 journey. How do we go from 1 to n at this point? And that's where I think a lot of this work on database as a service was inspired by direct conversations with a lot of our enterprise customers. They were loving using Couchbase, and then they were like, hey, but can you please also operate this database on our behalf? We don't want the operational overhead. And then scaling the database as let's say if there are millions of reads and writes happening, you want to scale the compute, you want to scale the storage. That's an overhead for customers. And that's where Capella and the need for Capella really came up. Our goal was to create a fully managed database as a service offering. But our database, as Couchbase, most of our customers were large-scale enterprise customers, usually in the financial and health sectors. They were scared or worried about and very deeply concerned about three things: confidentiality, integrity of their data, and availability. So at this point, security was like at the core of our DBaaS offering. We had to make sure that what we are building is guaranteeing a customer that their data is safe with us. It's not leaving the perimeters of private virtual cloud, and it's not going over the internet, for example. So that's where we built the generation 1 architecture of Capella. And at this point, we decided, let's provide a simple toolkit to customers with a simple control plane and a simple data plane. Except the data plane is completely owned and managed by the customer themselves. So all we did was we provided a management plane based on Kubernetes, and the infrastructure and the AWS accounts were all procured and fully owned by the customers. This ensured that there was data integrity and security because the data resided in the customer's AWS accounts. And Couchbase was just provisioning and orchestrating the database, scaling it up, managing and observing what's happening to it. So this worked really great for us when we started DBaaS in the V1 era, and it was a good inflection point. We were able to get customers migrating from on-prem onto cloud, but soon we started realizing a few difficulties. I think after we got our first few customers onboarded to Capella, the biggest problem that we faced as a DBaaS offering was the fact that all the infrastructure was deployed in the customer's AWS account. So we didn't really have direct access or certain privileged access to all the infrastructure that existed there. The configurations were all set up, and sometimes, due to some human errors, these configurations could be edited, and we had no control over it. That made supportability a big concern at that point. There was also, as a result, reduced agility, and it also kind of restricted us to upgrade our database version, for example. Because we actually had Kubernetes, even though there was no database compute deployed, and if customers required idle time to hibernate their clusters, we still had some amount of infrastructure continuously running in the AWS accounts. And that's where the infrastructure costs were kind of skyrocketing for the customers. And finally, because we used Kubernetes, and it was a fully managed offering at that point, right? We did not control the upgrades. They were kind of forced upon, and we had to rely on the upgrades as defined by the Kubernetes managed service. So at scale, we realized that we were building a cloud product, but was it really easy and maintainable? Was it extensible, right? And these were some of the questions we started asking ourselves. At this point, we decided there was a need for a generation 2.0. At this point, I think the thought of actually deploying and managing infrastructure in public cloud was the next generation or the next direction that Capella had to take. This is when we realized that we have to procure and manage our own AWS accounts on behalf of the customers, manage the infrastructure, while keeping in mind that data isolation and integrity are extremely crucial to customers. So DBaaS Generation 2.0 was built on 4 pillars. The first one was cost. I think the key goal to any company or any product is to lower the TCO for your customer. So if we went to them and told them, hey, you use Capella and we'll manage the entire cluster lifecycle for you, they'll be like, yes, but at what money, right? So our goal was to reduce the total cost of ownership for our customers by providing benefits and value-added services such as cluster hibernation, lean and very use case-driven configuration templates if somebody had a use case where they were using, say, mobile applications on a cruise ship, they would probably have a configuration where they have to deploy our edge management services as opposed to, say, a query engine, right? The second goal was to accelerate, which means as compared to our generation 1.0, where we had all of these barriers to adoption, where there were security concerns and upgradability concerns, the generation 2.0 was meant to accelerate the adoption by making it simple. So I think what I'm saying is, designing DBaaS, it was a big systems engineering problem, but at the core, we had to keep the architecture simple and manageable. Agility, that means it should have been easier to migrate from on-prem to cloud. If there's a customer that's already using Couchbase, how can we make it a one-click deployment or an easy migration onto the cloud without giving them downtime? Can we serve reads and writes on-prem as well as cloud at the same time and eventually just turn off the on-prem cluster? What did that journey look like? We had to really deeply think about that. And supportability, definitely we have a big support team because it's a fully managed offering. That means we are 24/7 supposed to be in support of our customers. So how can we make the support team's life easy? By giving them the levers and hooks to manage the infrastructure on behalf of customers. And I think these are such generic tenets that operate and apply to any company that you're trying to build from ground up. So a quick change in the generation 2.0, we had the same control plane, we had the same API clients. It's just that the data planes were now completely hosted and managed by Couchbase. What we did was if one customer, a brand new person or brand new user signs up on cloud.couchbase.com, we assign one AWS account, one GCP account, and one Azure subscription to that customer. And we deploy all the infrastructure for the customer in these dedicated, isolated cloud accounts. That's where you get your data isolation, security, and as well as scalability, because the entire account is yours. And then the customer applications can directly connect to whatever runs in the data plane via public internet or private internet. So I think when we started building DBaaS, we had to be really intentional. The intentionality was that we wanted to keep our core offering, which is the database, open source, because that's how we started off. And then we still wanted to leverage and provide value-added services to our customers by just hooking in operational features, such as multi-cloud orchestration, multi-tenant systems, billing, metering, providing valuable insights into workload monitoring, and so on. Even tighter access control and RBAC on cloud with IAM policies, let's say, on AWS. And there was a lot of benefit that people drew and our customers drew from that offering. So there was definitely benefit. So if we have to think of what it takes to build DBaaS, which is a simple architecture, easy to access, easy to maintain, while isolating data, security, and integrity, there are a few points that come to my mind. The first one is we built DBaaS as a multi-tenant platform, which means every time we onboard a new customer, we have to provision and assign a new cloud account to that customer, which means we have to maintain a pool of AWS cloud accounts and keep assigning those accounts to new customers as they sign up, which means we have to manage the quotas of all the AWS resources that we want to deploy, and that too on all AWS regions. So there's a whole new thing about data, about tenant onboarding and tenant isolation. That took us a while to build in the control plane. The second one is billing and metering accuracies. We have a lot of vendors today which make billing really easy and reconciliation easy, but metering is a very crucial aspect when it comes to building a billing system for the DBaaS platform. Actually counting the number of reads and writes happening on your database, sending that information out from the data plane, and reconciling on an hourly basis, on a monthly basis, And for whatever reason, if there is a failure where this data doesn't come out of the data plane, well, okay, I don't know what to do. So we face a lot of these pitfalls where reconciling at the end of every month, ensuring that we are billing our customers the right way, and we are being compliant, and we're able to prove that this is how much they used, and this is why you're getting billed for that much amount, was a challenge. Database availability at scale. The thing with databases is it's at the heart of any product. If a database goes down, you can't use your application, right? You'll see an error message, and that's a very bad experience. So all of our customers, and all of them use like a database and Couchbase at scale and at production. The main thing that is really important for them is high availability and zero downtime. To provide that in a DBaaS offering and also provide them with an ability to automatically scale their cluster and compute while keeping the data always available is a big challenge. It's a typical distributed systems problem where you have to spin up new compute before you remove the old one, but much more than that, right? So we were able to leverage some of the offerings that Couchbase has with multi-dimensional scaling, where you can scale query service separately, you can scale your indexing service separately, and it's really great. But just doing that in cloud is still a challenge. And especially building it from ground up, that's a big one. The customer journeys, and those really matter, right? So with DBaaS, if you have to sell any cloud product or any SaaS product, I think you need to think of how can we onboard customers and then give them the benefit of using this product before they pay us the money, right? So we had like different plans like free tier to enterprise and supporting our customers through the journey of transitioning from a free trial experience into a paid experience was also a big one because we had to migrate them. We had to ensure that for free tier, we bore the cost as a company. You know, the customer did not pay us. So our architecture, the control plane, and the data plane systems for free trial was completely different than our paid offering. And we had different challenges and different problems. With free tier, people just want to use and try the product. They want to see the benefit of Couchbase, but they don't really care about data isolation as such. So solving for different architectures and supporting different customer journeys meant that we had to actually support and keep enhancing the control plane at every step of the way. As Steve mentioned, Couchbase is not just a NoSQL database. We have mobile, and we serve agentic apps and workloads and big workloads at the edge, like with Princess Cruise Line and Carnival, right? Which means that we have a bunch of product lines, like Sync Gateway, which is our edge offering. We have an analytics database offering. We have vector search. And with every new offering, which is a differentiator of Couchbase, bringing it onto the cloud is yet another lever and a hook inside the control plane. We have to tweak the control plane at every point in time. So now think about it. Had this been easy to not keep changing the control plane each time, but to just purely focus on the differentiators that Couchbase has, would have really accelerated our journey. And of course, there's cloud provider differences. The control plane that we built had to be cloud agnostic. It had to be resilient and extensible. So doing that with the different cloud technologies that are there across AWS, GCP, or Azure, we had to keep supporting and keep in front of it all the time. Cool. So delivering a great DBaaS isn't just about running the database. It's much more. It's about actually building a platform that manages the infrastructure behind the scenes, and it does it so seamlessly that it's abstracted from the customer, but it's the most important and the crucial part for a good customer experience. And without that platform, just building DBaaS wouldn't have been possible. Another thing I think I learned the long way is that the journey of building Capella was not in days. It took us years to get here. It was a multi-year and a multi-architectural decisions-based journey. So it would have been really great if it would have been just a few months or a few days to build. you know. And the most important thing, customer experience is a really core systems engineering problem. We're all engineers at heart, and every time we are building a new tech product, we have to realize that some of the decisions that we make early on in our 0 to 1 journey catapult us into success in the 1 to N journey, right? So choosing the right tools in your 0 to 1 journey really matter. And that's where I think the way we decided to build Capella, the way we decided to adopt and position Capella, first starting off with AWS on the marketplace, and then with a managed offering with AWS, and then soon with other cloud providers, was really useful in that sense. A few success stories. Capella by the numbers. So after we launched the second generation, a fully hosted DBaaS offering, we were able to prove and show to our existing customers who are on-prem that moving to Capella would reduce their TCO by 40%. Had they have to manage and deploy the entire database by themselves, they would be paying 40% more than they would if they moved to Capella. There was a very fast developer adoption rate that we saw. Our free tier offering is perpetually free. Anybody can go and sign up on cloud.couchbase.com, spin up a cluster, try it out, even use it for a long time. So it's completely free forever. You don't need a credit card, anything at all. So we saw that when we launched this perpetually free trial experience, almost 60% of those signups converted to paid offerings, which was great. And some of our biggest enterprise customers, like Princess Cruise Lines, Carnival, they're all on-prem. Migrating them to Capella was a breeze. They are now migrating, and 3x of their workloads have been migrated. So I would like it if you all can go to cloud.couchbase.com, sign up, and just check it out. It's an open source database, which is NoSQL, fast, and it's meant to serve all different types of applications, from agentic AI to mobile applications. You don't have to worry about data schemas. You don't have to worry about evolving data schemas because it's all JSON and it has no structure. We also, by the way, support agentic apps for unstructured data, so that's available too. And these are some screenshots from the website as well that please do check out.